Hi, my name is Dawit Ayub, I am from Asmara, Eritrea. I have taken CS50 Cybersecurity 2023, and here is my final project presentation. The topic that I decided to look into is the Log4j vulnerability. Log4j is one of the highly ranked cyber threat which affects environments that use Java in their systems. And since Java is widely used in various applications, this makes Log4j a major threat to the health of systems. The reason I decided to look into this topic is as an aspiring junior developer myself, I know that I will use Java-based applications, plugins, frameworks etc. in the projects that I will be developing or participating, so it looks compelling to try to understand a little about the vulnerability. So, without a further ado, let's look at what Log4j is. In the following slides we will look into a couple of issues like: what is Log4j? What impact does it have on systems? How does it work? What means and method does we have to protect ourselves from that kind of attack? And last, we will look into some of the impacts this vulnerability had on the world. As the name might hint, Log4j is a logging library, widely used in Java-based applications for effective logging and debugging. It's an open-source logging framework in Java that developers use to track software activity in cloud and enterprise apps. It runs on background of web application and it is used to store end users and the application's activities. As I have said above, it is a Java-based framework, so it used in almost every application since Java is a very popular application and used in almost every application nowadays. And the importance in logging and tracing the software event is helpful for application troubleshooting and monitoring. So, if it has this importance, what is the problem that raised then? On December 9, 2021, a zero-day vulnerability in the popular Log4j logging framework for Java was first published, and it was given a CVE number by NIST. CVE 2021-44228. And also, the vulnerability CVE 2021-44228 was given a score 10 out of 10, which is highly critical and significant as NIST rarely scores vulnerabilities a 10. CVE 2021-44228 was found to allow RCE, remote code execution, and also it can easily be exploited, since there are dozens of proofs of concepts for exploit available online. Many attack groups including nation-state actors and ransomware groups have added exploits for the vulnerabilities to their attack kits and are using them to establish reverse shells, drop remote access toolkits, and carry out hands-on keyboard attacks on vulnerable systems. One real-world method that attacks use the Log4j vulnerability is the method usually known as buffer overflow. Buffer overflow is an attack that exploits programming mistakes to overwrite the memory of a computer system, enabling malicious actions, such as RCE, remote code execution, data leak, and more. Its goal is to introduce a system or kernel crash by overflowing the memory buffer reserved for the application. Once the application or system crashes, the goal is to insert malicious data in the memory buffer where the application was residing. From there, a common technique is to attempt to jump into a more privileged place in memory. Suppose the attacker have gained some info about the system through some other method that this system collects some user info and stores them in memory, and let's say usually the information collected are of 8-bit size. Then the attacker intentionally alters his machine to send a 10-bit size data instead of the 8-bit it was supposed to send, but he would separate the 10-bit data into two different parts, namely first the 8 bits to be the correct data and the other 2 bits would be a carefully designed piece of code, which is mostly in assembly language. When the logging system receives this 10-bit data, it would continue the usual execution thinking it received a proper data, so it will try to store it in memory as it was instructed to do so. But the system only allocates 8-bit from the memory array, but it received a 10-bit data, so it will store the 8 bits one by one in the allocated memory, and when it reaches on the 9th and 10th bit it will jump into the memory and store them in the following space without checking if the space was reserved or free. Now the memory has some foreign data which was not supposed to be stored in there. This foreign data can be anything which the attackers have designed to their needs. For the sake of this presentation, we will look into the example where the foreign data is a piece of assembly code which instructs the system to download another malware that will turn the system in a cryptocurrency mining machine. According to an article written by Andy H. on the Security Boulevard, in order to make a successful buffer overflow attack, one passes 3 distinct steps. Exploit, to gain access into a system. Shellcode, a piece of code to inject to perform a certain action. Payload, a code that performs the attacker's intention. In our example above, the exploit is the Log4j vulnerability that gives the attacker unauthorized access to the backend of the system. The shell code is the piece of code included in the last 2 bits of the input given by the attacker into the system, and last the payload is the application code downloaded by the system under the command of the attacker to mine cryptocurrencies. So, the process follows all the steps one by one: exploit, shell code / code injection, and last the payload. Some of the impact of Log4j on systems worldwide are: 1. Widespread security breaches. It exposes critical systems and allows malicious actors unauthorized access into systems and databases. 2. Reputational damage. Significant reputational impact on the affected organization and potential costs associated with the breach. 3. Business disruption. The cascading effect of the Log4j vulnerability on various industries and organizations around the world. 4. Misuse and abuse of resources. This vulnerability can disrupt critical systems, resulting in operational downtime and financial losses. How can one protect his system and data from such attacks? Rapid patch deployment. Enhancing log monitoring. Employee awareness training. Upgrade to safe versions. Strict input validation. Security audits. In addition to the above mitigation techniques, continuous monitoring and analysis should be deployed in every infrastructure with enough hardware, software, and experienced staff. A working and feasibly response plan should be designed and placed in every data center to minimize any harm on the system. And patching should be as frequent as possible on every aspect of the system. Some notable incidents: Lazarus Group using Log4j exploits to deploy remote access Trojans in 2023. Iranian hackers exploiting unpatched Log4j2 bugs to target Israeli organizations in 2022. Hackers exploit Log4j vulnerability to infect computers with Consari ransomware. At the end, what lessons do we learn from all those attacks? Third-party risk management. Cyber attack emphasized the importance of robust third-party risk management processes to mitigate vulnerabilities. Security hygiene best practices. Essential security hygiene practices that organizations should adopt to minimize the risk of similar vulnerabilities. Effective incident response. Need for well-defined and tested incident response plans to enable swift and efficient response during cyber attacks. Organizations should look the Log4j situation to take a step back and answer the following fundamental security and risk management questions. What is our plan? How will we know if we're being attacked, and can we respond? What visibility do we have to our software, servers, and critical data? How are we addressing shadow IT/appliances? Do we have significant third-party risk? Thank you.